Welcome to Tactic Techniques, Ansible Scenario Based and Real-Time Interview Questions and Answers. How do you set up Ansible? To set up Ansible, you need to perform the following steps. Install Ansible. You can install Ansible using a package manager, such as apt or yum, depending on your operating system. Alternatively, you can install it using pip, the Python package manager. Set up an inventory file. Ansible uses an inventory file to define the servers it will manage. You can create an inventory file by creating a plain text file and listing the host names or IP addresses of the servers you want to manage. Configure the Ansible host. You will need to configure the host running Ansible to be able to connect to your managed nodes. This involves setting up the necessary credentials and firewall rules. Write a playbook. A playbook is a YAML file that defines a series of tasks that Ansible should execute. You can use playbooks to automate a wide variety of tasks, such as installing packages, copying files, and creating users. Run the playbook. Once you have written your playbook, you can run it using the Ansible playbook command. Ansible will then connect to each of the servers listed in the inventory file and execute the tasks defined in the playbook. Here's a simple example of a playbook that installs the Apache web server on a set of servers. Name, install Apache. Hosts, web servers, become, yes, tasks. Name, install Apache, package. Name, Apache 2, state, present. This playbook defines a single task that installs the Apache web server using the package module. The become, yes line specifies that Ansible should run the task with root privileges, and the hosts, web servers line defines which servers the task should be executed on. The servers are defined in the inventory file, which might look something like this. Web servers, server1.example.com, server2.example.com. You can run this playbook using the following command. Copy code, Ansible playbook apache.yml. What happens when the Ansible master node fails? When the Ansible master node, also known as the control node, fails, it can cause disruptions to your automation tasks, especially if you rely on that node to manage other nodes in your infrastructure. In case of a failure, you can either switch to another control node or set up a new control node. If you have multiple control nodes, you can configure them to use an active/passive configuration where one node takes over if the other fails. If you have no backup control node, you may have to set up a new control node and reconfigure the inventory and playbooks to reflect the change. You may also have to wait until the failed control node is repaired or replaced, depending on the cause of the failure. To minimize the impact of a control node failure, it's recommended to regularly back up your configuration, including playbooks, inventory, and settings, so that you can quickly recover and resume automation tasks. How do I recover my master node in Ansible? To recover the Ansible master node, you can follow these steps. Back up your configuration. Before proceeding with the recovery, make sure to back up your Ansible configuration, including playbooks, inventory, and settings, in case anything goes wrong during the recovery process. Stand up a new control node. If the master node is completely down, you need to set up a new control node. You can use the same machine or a different one. Restore the configuration. Once the new control node is set up, restore the backup of your Ansible configuration to the new node. This includes playbooks, inventory, and settings. Update the inventory. If you have any nodes managed by the failed master node, you will need to update the inventory file to reflect the new control node's address. Test the new control node. After you've completed the recovery, test the new control node by running a simple playbook to ensure that it's working as expected. Consider setting up a secondary control node. To minimize the impact of a control node failure in the future, consider setting up a secondary control node. You can configure it to take over if the primary control node fails. Ansible Tower is a web-based platform that provides centralized management and automation for IT operations. It is designed to simplify and scale Ansible automation by offering a user-friendly interface, role-based access control, real-time job status, and many other features. Some of the key features of Ansible Tower include user-friendly interface. Ansible Tower provides a graphical user interface for managing and automating IT operations, making it easier for teams to use Ansible. Role-based access control. Ansible Tower allows you to control access to your automation content by defining roles and permissions for different users and teams. Real-time job status. Ansible Tower provides real-time visibility into the status of your automation jobs, including job history, output, and logs. Scheduling and notifications. Ansible Tower allows you to schedule jobs and receive notifications when jobs complete or fail. Integrations. Ansible Tower integrates with other IT tools and systems, including cloud platforms, CMDBs, and ticketing systems. API and CLI. Ansible Tower provides an API and a command line interface, allowing you to automate and integrate your automation workflows. Ansible Tower is ideal for organizations with complex automation requirements, multiple teams, and large infrastructures. It helps to streamline and standardize your automation workflows, making it easier to manage and maintain your automation content. Ansible Galaxy is a public repository of Ansible roles and collections, where users can share and find pre-written automation content. It provides a vast library of rules that can be used to automate a wide range of tasks, making it easier to get started with Ansible. Some of the key features of Ansible Galaxy include: Role Library. Ansible Galaxy provides a library of roles that you can use to automate various IT tasks, such as installing software, managing configuration files, and deploying applications. Search and download. You can use Ansible Galaxy to search for and download roles that meet your automation needs, saving you time and effort compared to writing the code from scratch. Share and collaborate. Ansible Galaxy provides a platform for users to share and collaborate on roles. This makes it easy for others to build upon and improve existing automation content. Ratings and reviews. Ansible Galaxy provides a way for users to rate and review roles, helping others to determine the quality and usefulness of the role before using it. Continuous integration and testing. Ansible Galaxy provides tools for continuous integration and testing, ensuring that roles are of high quality and compatible with the latest versions of Ansible. Ansible Galaxy makes it easier to get started with Ansible and speeds up the process of creating automation workflows. In Ansible, handlers are a way to trigger specific actions in response to events, such as a change in the state of a managed node. Handlers are defined in a separate section of an Ansible playbook, and they are executed only if they are notified by tasks. Here is an example of a handler in an Ansible playbook. Name: ensure Apache is started. Service: name, Apache 2. State: started. Notify: restart Apache. Name: ensure Apache is restarted. Service: name, Apache 2. State: restarted. Notify: restart Apache. Handlers: name, restart Apache. Service: name, Apache 2. State: restarted. In this example, the two tasks ensure Apache is started and ensure Apache is restarted both notify the handler restart Apache whenever they change the state of the Apache service. This allows the playbook to ensure that the Apache service is running and restarted whenever necessary, without having to repeat the same commands in multiple tasks. Ansible modules and its types. Ansible modules are small, reusable units of code that perform specific tasks on managed nodes. They can be used to perform various types of operations, such as installing packages, creating files, starting services, and much more. There are two types of Ansible modules: core modules and extra modules. Core modules. These modules are included with the base Ansible installation, and they cover a wide range of tasks and functions, including file and directory management, package management, user and group management, and much more. Extra modules. These modules are not included with the base Ansible installation, but they can be installed as needed. They provide additional functionality, such as cloud resource management, database management, and network management. Here are some examples of commonly used Ansible modules. apt manages packages on Debian-based systems using the apt package manager. Copy copies files from the local system to managed nodes. File manages files and directories on managed nodes. Service manages services on managed nodes. User manages user accounts on managed nodes. Yum manages packages on Red Hat-based systems using the Yum package manager. ec2 manages resources in Amazon Web Services, AWS, Elastic Compute Cloud, EC2. MySQL_DB manages MySQL databases. PostgreSQL_DB manages PostgreSQL databases. Linian file, adds, changes, or removes a line in a file on managed nodes. Ansible inventory and its types. Ansible inventory is a list of managed nodes and their attributes. It is used to specify the targets for Ansible operations, such as running playbooks and executing ad hoc tasks. There are 3 types of Ansible inventories: static inventory, dynamic inventory, and custom inventory. Static inventory. This type of inventory is specified in a static file, usually in the ini format. It lists the managed nodes, their host names or IP addresses, and any relevant attributes, such as the SSH username and the private key file. Example of a static inventory file: web servers, web1 Ansible_host equals 192.168.1.100 Ansible_user equals Ubuntu. Web2 Ansible_host equals 192.168.1.101 Ansible_user equals Ubuntu. DBS servers. DB1 Ansible_host equals 192.168.1.102 Ansible_user equals Ubuntu. DB2 Ansible_host equals 192.168.1.103 Ansible_user equals Ubuntu. Dynamic inventory. This type of inventory is generated dynamically, often using a script or a plugin. It can retrieve information about managed nodes from cloud providers, network devices, or other sources, and it can also use variables to set node attributes. Custom inventory. This type of inventory is created using a custom Python script or module. It allows users to define custom inventories tailored to their specific needs, such as grouping nodes based on custom attributes, filtering nodes based on dynamic criteria, and more. In Ansible, the inventory is specified using the I option, and it can be a static file, a dynamic inventory script, or a custom Python module. The inventory can also be specified as a comma-separated list of inventories, allowing users to combine different types of inventories and use them together in a single operation. Ansible architecture. Ansible is a decentralized IT automation tool that uses a simple, human-readable language to describe the desired state of systems and the operations required to reach that state. It follows a client-server architecture, where the control node acts as the client, and managed nodes act as the servers. The architecture of Ansible is composed of the following components. Control node. This is the machine where Ansible is installed and executed. It contains the playbooks, modules, and configuration files that describe the desired state of the systems and the operations required to reach that state. Managed nodes. These are the systems that Ansible manages. They can be physical servers, virtual machines, cloud instances, network devices, or any other systems that can be accessed over a network. SSH. Ansible uses SSH to communicate with managed nodes and execute commands. SSH is a secure and reliable protocol that provides encryption and authentication, and it is widely used in Linux and Unix systems. Inventory. The inventory is a list of managed nodes and their attributes, such as host names, IP addresses, and SSH credentials. Ansible uses the inventory to target specific systems for operations. Playbooks. Playbooks are the main building blocks of Ansible. How to configure Ansible cluster. Configuring an Ansible cluster involves several steps, including installing Ansible on the control node, defining the inventory of managed nodes, and creating and running playbooks. Here is a general outline of the steps involved in configuring an Ansible cluster. Install Ansible on the control node. Install Ansible on the machine that will act as the control node. This can be done using a package manager, such as yum or apt, or by downloading and installing the source code from the Ansible website. Define the inventory. Create an inventory file that lists the managed nodes that Ansible will manage, along with their attributes, such as host names, IP addresses, and SSH credentials. The inventory file can be in several formats, including ini, YAML, and JSON, and it can be stored in a variety of locations, including a local file or a remote file. Create playbooks. Create playbooks that describe the desired state of systems and the operations required to reach that state. Playbooks can include tasks, variables, conditionals, loops, and other elements that allow users to automate complex IT operations. Configure SSH. Configure SSH on the control node and managed nodes to allow Ansible to communicate with the managed nodes and execute commands. This typically involves generating an SSH key pair on the control node and copying the public key to the managed nodes. Test the connection. Test the connection between the control node and managed nodes by running a simple Ansible command, such as Ansible all mping, to see if the managed nodes are reachable and responsive. Run playbooks. Once the inventory, playbooks, and SSH configuration are in place, run the playbooks using the Ansible playbook command. This will execute the tasks in the playbooks on the managed nodes and configure them to match the desired state. Monitor and troubleshoot. Monitor the results of the playbooks and troubleshoot any issues that may arise. Ansible provides a variety of tools and techniques for monitoring and troubleshooting, including logging, reporting, and error handling. In summary, configuring an Ansible cluster involves installing Ansible on the control node, defining the inventory of managed nodes, creating playbooks, configuring SSH, testing the connection, running playbooks, and monitoring and troubleshooting. By following these steps, you can create a flexible and scalable Ansible cluster that can automate complex IT operations with ease. How to configure SSH in Ansible? To configure SSH for use with Ansible, you need to generate an SSH key pair on the control node and copy the public key to the managed nodes. Here is a general outline of the steps involved in configuring SSH for use with Ansible. Generate an SSH key pair. On the control node, run the following command to generate an SSH key pair. SSH keygen TRSA. This will create a private key in the /.ssh/id_RSA file and a public key in the /.ssh/id_RSA.pub file. Copy the public key to the managed nodes. Use the SSH copy ID command to copy the public key to each of the managed nodes. For example, to copy the public key to a managed node with the IP address 192.168.0.100, run the following command. SSH copy user at 192.168.0.100, where user is the username on the managed node. Repeat this step for each of the managed nodes. Configure SSH in Ansible. In the Ansible configuration file, ansible.cfg, set the remote_user parameter to the username that you use to copy the public key to the managed nodes. This is the username that Ansible will use when connecting to the managed nodes over SSH. For example, defaults, remote_user equals user. Test the connection. To test the connection between the control node and managed nodes, run the following command. Ansible all mping. This will use the ping module to check if the managed nodes are reachable and responsive. By following these steps, you can configure SSH for use with Ansible, allowing Ansible to securely communicate with the managed nodes and execute commands. You can also specify a different SSH key for Ansible to use by setting the Ansible_SSH_private_key_file parameter in the inventory file or in a playbook. This can be useful for managing multiple SSH keys for different environments or accounts. Ansible Key Vault refers to the secure storage of secrets, such as passwords, tokens, and other sensitive information, that are used by Ansible playbooks. This allows organizations to store secrets in a central location and manage access to them, rather than hard-coding secrets in playbooks or leaving them in plain text files. Ansible provides several ways to integrate with key vaults, including Ansible Vault. Ansible Vault is an encryption feature built into Ansible that allows users to encrypt sensitive data in playbooks, inventory files, and other files. This is useful for protecting secrets and other sensitive data that needs to be stored in plain text files. External key vaults. Ansible can also integrate with external key vaults, such as HashiCorp Vault, CyberArk, and others. This allows organizations to store secrets in a central location and manage access to them, and then use Ansible to retrieve the secrets as needed. How to write an Ansible playbook. An Ansible playbook is a YAML file that defines the tasks and operations that Ansible should perform on managed nodes. Here's a general outline of the steps involved in writing an Ansible playbook. Define the inventory. In your playbook, specify the list of managed nodes that you want to target. This can be done using the host section of the playbook. For example, name, my playbook, hosts, web servers, become, yes, Become_user, root. In this example, the playbook is targeting a group of managed nodes called web servers. The become and become_user parameters specify that the playbook should be executed as the root user. Define tasks. In the playbook, define the tasks that you want Ansible to perform on the managed nodes. Tasks are defined using the tasks section of the playbook. For example, tasks: name, install Apache, yum, name, httpd, state, present, name, start Apache, service, name, httpd, state, started, enabled, yes. In this example, the playbook is installing the Apache web server and starting it on the managed nodes. The yum and service modules are used to perform these tasks. Run the playbook. To run the playbook, use the Ansible playbook command, followed by the name of the playbook file. For example, Ansible playbook myplaybook.yml. This will run the playbook and execute the tasks on the managed nodes defined in the inventory. The output of the playbook will show you the results of each task, including any errors or failures. Explain the best practices for Ansible debugging. Here are some best practices for debugging Ansible playbooks. Use verbose output. Use the VVV option when running the playbook to increase the verbosity of the output. This can help you see what's happening behind the scenes and diagnose any issues. Check return codes. As mentioned earlier, Ansible playbooks return a non-zero exit code when a task fails. You can use the echo $ command to see the exit code after running a playbook. Debug task by task. If a particular task is failing, you can add the debug module to that task to inspect its state. You can then use the T option to run only that task and see the output of the debug module. Check log files. Ansible writes log information to a file by default. You can use the VVV option when running the playbook to increase the verbosity of the log output, making it easier to see if any errors have occurred. Validate syntax. Use the Ansible playbook syntax check command to validate the syntax of your playbook before running it. This can help you avoid simple mistakes that might cause the playbook to fail. Use Ansible Vault for sensitive data. If you have sensitive data, such as passwords, that you need to use in your playbook, consider using Ansible Vault to encrypt it. This can help ensure that sensitive information is not exposed in log files or other outputs. By following these best practices, you can make debugging Ansible playbooks easier and more efficient, allowing you to quickly identify and resolve issues. Let's say you have a web application that runs on a cluster of servers, and you want to automate the process of deploying updates to the application. Here's how you might use an Ansible playbook to accomplish this. Create a playbook that defines the tasks needed to deploy the updates to the web application. For example, you might need to copy the updated files to the servers, stop the web server, start the new version of the application, and then restart the web server. Define the list of servers that make up the cluster, and store this information in an Ansible inventory file. Run the playbook, specifying the inventory file and the tasks defined in the playbook. Ansible will then execute the tasks in order on each server in the cluster, deploying the updates to the web application. Monitor the output of the playbook to ensure that it runs successfully on each server. If there are any issues, you can use the debugging techniques discussed earlier to determine the cause and resolve the problem. By using an Ansible playbook in this way, you can automate the process of deploying updates to your web application, reducing the time and effort required to deploy updates, and helping to ensure that the updates are deployed consistently and accurately across all servers in the cluster. Thanks for watching and please subscribe my channel.